Hello, this is Jesse, and today I'm going to be going over RAS-TK. And the objective of this tutorial is to cover the basic use of commands at the command line in the Iris environment to extract information from an annotated genome in GFF3 format. So first, I give you this URL right here to the command line environment Iris, which is provided by the RAS developers. You can use this, or you can go to RAST, and you should already have, at least by now, a RAS account set up. And at the homepage of RAST, you can go on to right below where it says what is RAST. Second label right here, just click on the Iris and RAS-TK workshop presentations and tutorials, and go where it says tutorials, click on getting started with RAS-TK, and you can also get to Iris from here. Click on Iris and it will open it up for you, and it'll take you to the Iris command line environment. So at this environment, this is where we will do most of the we will be doing most of the tutorial here. And here, notice how I'm already logged in here. You will need to log in yourself. Just use your login and password for RAST, and that will work. And next, we need to get a genome. But before that, I'm going to just go over some basics of the command line environment. So here we have the command console, and below is this little input box where you can actually type in commands, and when you press enter, you will have output given out in the command console. Okay, and then here is command list. You'll have different commands you can look through here, and it'll show you what options you have for the commands. And then you have a file browser. So these are the files for your account. Here I already have some files here uploaded. You probably already have no files, at least for now, but in this tutorial you're going to have a few made. So first, let's just go over using commands. So the first command we'll go over is ls. ls will list the contents of the folder you are in, or the directory. Okay, so if I say directory, I'm just talking about the folder that I'm currently in. So right now I'm in the home directory, so I type ls. It's going to give me all of these folders or files that are in the home directory. Okay, so here we have what's being listed. So it's all this right here is put out ls. The output is just the contents of the home directory. Now, what if I want to see from the command line what's in tutorial 13? Well, what I can do is I can use the command cd. So I can use it to change directories to tutorial 13. So cd space, and then I'm going to type in the name of the folder that I want to go to. Okay, so tutorial_13. Change directories. Here I can type ls now because I just changed into tutorial 13 directory, and it'll give me what's inside the tutorial 13 directory. Here's all what I have. Now, additionally, what if I want to make a directory? So I can type in mkdir for make directory space, and I'll call this example, and then type in ls. So I made a directory called example, and now I have a directory called example in the tutorial 13 directory. Next, what if I want to move one of these files into this directory? Well, all I need to do is use the command mv, and then I'm going to tell the command where I want to move it and what I want to move. So first, I'll type in mv space, and I want to move tutorial 13.fna, so this file right here, I want to move it to the example directory. and then it'll tell me that I moved tutorial 13 underscore 13 or tutorial underscore 13.fna to example. Type in ls and you see that there's no tutorial underscore 13.fna anymore. That file's gone. It should be in this directory. So just like previously, if we want to change directories, we just type in cd space and the name of the directory. Good, so now we have moved to the example directory. So we're inside of this file, this folder right here. So we can type in ls now, and we should see our tutorial 13.fna. So that's how you make directories, and or move files. You can also move folders too, or move other directories around. But let's say I want to move this file back out in tutorial 13. So I can type in move, and I still want to move tutorial 13. I want to move this file, tutorial underscore 13.fna, but I want to move it to tutorial 13, so I want to move it back one more folder. So all I need to do is give the underscore, or not underscore, the /, and then type in tutorial underscore 13. Okay, so move space what I want to move, where I want to move it. Okay, I put the underscore, I put the / to say that I want to move it to a directory. Okay, so type in enter, and then I have the results right here telling me that I just moved this file to this folder, okay, or this directory. Now, I'm still an example right now, but I want to move back one to tutorial 13. So what I need to do is type in cd, and I can type ... press enter, and it's going to move me back into tutorial 13. Type in ls. Now I have my file here back to its original place, an example. Okay, now I can go back into example, and this I'm going to show you how you can use past commands that you've used by using the up key. So I type up key, or I press the up key. It's giving me commands that I've used in the past. So here I want to change back into the example directory. So I press enter, change me back, type ls, there's nothing there, okay? So now I'm just going to change back out, and I'm going to remove this example directory, type in ls. I don't want this to be here anymore, so I'm just going to type in rm for remove, and then I'm going to put dr for directory, remove directory, and example. And then list. So this is gone now. Okay, so that's some basic commands for moving around in your directory, and moving around in your directory, shuffling and moving to your certain files, removing files, and removing folders. If I wanted to remove one of these files, then I just type in rm for remove, and then you can type in the name of the directory. In this case, I don't want to remove any file, or to remove any files, rm, and then type in the name of the file. Name of file. Okay. And then remove directories is rm dir, and then the name of the folder or directory. Okay. So now let's get into our getting a genome now, since we've gone over some of the basics of using the command line environment. And I will show throughout this tutorial some more commands. So first, let's get a genome here, which is going to be a practice genome. So we can go to NCBI, and then we can just I give you the taxonomy ID. So taxonomy, just to make things easier for you, type in the ID into the search bar, click on the name of the organism, then on the right where it says the Entrez records, go to genome, click on the pink one, and then we're going to brought to the genome. page for the organism. Okay, and then you can save the genome here. So here in the tutorial, you just save the genome, and you just need to extract it. So genome, you're saving it right here. Bring it out to the desktop or wherever you want to save it as, and then you're going to type in extract. So once you've extracted so I've extracted it here, go to desktop, and then here's my extracted file right here, my extracted genome, and then you can name it, rename it, genome, whatever you want to name it. Okay, and then next what I'm going to do now is I'm going to upload it to the command line environment, the Iris command line environment. So I'm going to go here, I can go to file browser, okay, click where it says upload a file at the bottom right. I'm going to scroll down or find where I downloaded my file, and I'm going to click on genome.fna, and you're going to click open. Okay, once you click open, it should be downloading. Here it is, genome.fna. And now I've already done this, but I've already have the same genome. So you click on this, it's going to open it up in the browser, the genome right here. So you just have it in the file browser, and then same thing, this is the same, I've already done this before, so I already have it right here. But I made a directory and I moved the genome into this directory. So this file is going to go inside here. So what I would do is I type in move. Well, first I need to double check what directory I'm in. Right now I'm in the Tutorial 13 directory, so I want to get out of here. And then I want to list the contents. I want to move genome.fna to the Tutorial 13 folder. Okay, so all I'm going to do is go to type in move genome.fna to Tutorial 13. List contents. Genome is gone. Change directory. Tutorial 13. List directory. And then here it is, genome.fna. Okay, but that was just an example. I really don't want it to be here, so I'm going to remove it. And then that's gone. List directories. And genome, oh, spelled it wrong. Okay, now I list, and then that should be gone now. Yes, it's gone. Okay, so now we have, so in this case, I just showed you how to upload the genome, and then you can move it to your directory where you can work to keep things organized. Originally, I have mine already saved as tutorial_13.fna. Next, what we need to do is we need to turn this and get this ready to submit for RAST to annotate it for us. To do this, we are going to be using the create genome command. Okay, so here it is in the tutorial right here. So RAST create genome. So what we're going to do in the command line is you can type RAST create genome -help or -h for help, and it's going to tell you how to actually use this command. Okay, so here it takes, you need to type in RAST create genome, okay, exactly like how it's presented right here, and then we can give it some options. Here are some of the options, and then we're going to put in the file, and then we're going to name what we want the output to be. So in this case, we're going to type in RAST create genome, and then we're going to type in scientific name, and then we're going to give the scientific name of the organism. In this case, I already have this for y'all. Just type in or copy and paste in the file, and we're going to put these in quotations. So RAS create genome space, and then you see how it says dash dash scientific dash name, and then str for string, which is going to be the quotations and lactobacillus and the organism name right here. Okay. Next, what's going to happen is we're going to do another space and then dash dash, and we're going to type in domain. So I'm getting all this from right here, and I already have this for you all coded out. So domain, and then I'm going to give domain and put bacteria, and then genetic code. So genetic code, and then you're going to give it an integer. We're going to give it 11 for bacterial genome. So genetic code, and then we'll give 11. Then we're going to give contigs. So this is going to be the genome itself. Tutorial. I have it saved as tutorial underscore 13.fna. And then the output is going to be lacto. This is what I'm naming it. I'm going to name the output of the annotation job lactobacillus. Lactobacillus.gto. And then you click submit, and it will start running the job. Oh, this is just creating the genome. So once you create it, it's going to create a genome object. Okay, genome object right here. This right here is going to prepare it for annotation. I hope I did not say we're going to, this will annotate it. It will not. This will prepare it to be annotated. You would need to create a Java object, and then we will submit it to the, we'll use the RAS command to actually submit it to the server for it to be annotated. Okay. So this command right here will make an object that will submit it for annotation. Okay, I hope that's clear. Next, we're going to use another command, ras.process genome, and we type in -help, and it'll tell me what I need to do. So this right here is all we need to do is we're going to use RAS process genome, and then we're going to submit what we want, and we're going to name our output. So in this tutorial, I already have it. I submit the lactobacillus.gto, and then I'm going to name it lactobacillus underscore annotation.gto, and that's already in here. Right here, but I'm going to type it in just to show you. So ras.process genome, and it's going to be lactobacillus.gto, and then I'm going to name the output of the annotation job as lactobacillus underscore anno.gto. Okay, so this right here is going to submit the annotation job, submit it to the RAS server. RAS is going to run the algorithms to find the genes and the proteins and whatever you're annotating for. Okay, and then once you get the job, once it's done, you're going to get back a file named lactobacillus underscore anno.gto. Okay. Next, we move on to actually extracting the information that we want. What was annotated? How many coding domains are there? How many RNAs are there, and so forth. Okay, and we're going to be using the RAS export genome. RAS export genome -help, and then here are some commands that we can use. So the first one is we're going to use feature data, tabular form of a feature data. So what we're going to do is we're going to type in RAS export genome. We're going to type in feature data, and then we're going to input the lactobacillus_ano.gto, and then we'll output. We're actually not going to put any output. We're just going to look at the results. So RAS export genome feature data, and then the output is going, or the input is going to be lactobacillus_ano.gto. Okay, so it's truncated to 100 lines because it's going to waste a lot of memory if it did the entire annotation that it got done. So here is the file. Let me just increase this. Here are all our annotations here. Notice in the third field we have the actual type right here. We have some of the identifications right here, a session numbers, and then we have the FASTA file. So if you were to look at this in FASTA format, you would have this being the actual tag. The first part would be the greater than symbol, and then this right here, and then you would have underneath it the actual protein sequence. But we're interested in this part right here. We want to know what features were annotated. So what we can do is we can type an up command, and then what we can do is we can use a thing called a pipe. So this right here, this line right here, this pipe. Okay, so we're going to type in the pipe, just this line, and then we're going to take this output. I just showed you what this output is. It's this file right here, all this data right here. We're going to take out this output right here, and we're going to use another command. We're going to cut out this third column. Cut, and then it's going to be filled 3. Okay, and I'm going to press enter, and then we should just get this third column, right? See, so we just get a whole bunch of CDSs, maybe some whatever else was annotated, repeats, okay? So all I did was took this output, and then I'm going to pipe it into the cut command. The cut command is going to cut at the field 3. In this case, we're going to cut at field, we're going to cut out column 3. Then we're going to output this command, this result right here, this result. We're going to output it into another command called sort by unique identifier. So this time we're going to take, so you might see how there's a whole bunch of CDSs here. It's just going to take in and just give us the unique objects that are coming back, the unique features that were annotated. So we shouldn't get a whole bunch of CDSs. We should get one CDS, one RNA, other features, right? RNA, repeat, CRISPR spacer, CRISPR repeat, CRISPR array, CDS. These are the features that we can use and start pulling out from our annotation file. Maybe we want all the CDSs in FASTA format. Maybe we want all the RNAs. Maybe we're interested in the CRISPR arrays and we only want to file CRISPR arrays. Okay? Maybe the CDSs, might have a hypothetical protein that you're interested in, or you might want to investigate some hypothetical proteins. So we can start filtering out the data and only get the coding domains, right? Or maybe we only want some RNA, okay? I'm going to show you how to do that. Okay, so we're going to move on. Just went through this, and this tutorial will give you step-by-step instructions on how to use the commands we just went through. And we're going to going straight into extracting out all the CDSs, all the RNA, and then create a file with CRISPR arrays. So we can type in, we can go to here, and we can type clear. This will clear the console. We can type in ls. And what we want to do is we want to use the rast export genome -help just to remember what we have here. So let's go to, we're going to bring out CDSs. So we'll look at protein.fasta, and then we'll do feature type CDS. So I'll just type it here, rast export genome. From here, what I'm going to do is I'm going to type in feature type. We already just looked at all the features, right? We have the CRISPR array, we have the CRISPR repeat, CRISPR spacer, we have repeat alone, and then we have RNA and CDS. So we already know what types there are. So rast export genome feature type CDS. Then I'm going to take the protein FASTA. Okay, protein FASTA. Okay, so FASTA. Then I'm going to input the lactobacillus no.gto, and then see if that works. Let's see what I did wrong here. What did I do wrong? Oh, okay, let's see. Let me remove that. Okay, so here it is. We have just a snippet of all the CDSs that we have. So I can save this result. It's going to truncate it. It's not going to tell me. See, it's truncated 100 lines. Okay, and here we have some hypothetical proteins too. But these are all the coding domains, all the proteins. Okay, and we can output this into a file. Say we want to output this into a file called all CDSs and lactobacillus bacillus.fasta. Remember, we are going to export the CDSs in FASTA format. They're going to be proteins, and we are going to output them into the file called allcdss.lactobacillus. Okay, I already have this done. Just type in ls, and here is lactobacillus.fasta. So if you were to run that command I just showed you, you would have this. Every single CDS in protein and FASTA format. Okay, so all the protein sequences of the CDSs, right? Maybe some of these, maybe you're interested in some, maybe you're not. It's up to you. Just showing you on how to get all the CDSs here. Okay, moving on. What was next? This is going to be all RNA. So we're going to do rast export genome, feature type, RNA, and then it's going to be feature DNA. So we go back up here, right here, feature DNA. Feature DNA, and we're going to press enter and then see if this works. And here's our results. So here we have some of all the RNA, okay, of this organism outputted. It's truncated, obviously, like I told you. It's not going to output every single sequence into the command console because it's going to be, it doesn't need to, right? You can just put it out into a file and look at it there. It's going to cost a lot of memory to output all this, all the RNAs there. Okay, and then we can also do CRISPR arrays. That's what we have here. Yes, all CRISPR arrays, and it's the same thing. Same thing here. And just to recall, if you forgot, we go all the way up to where we have our command. Oh, it looks like it's gone actually. Well, that's okay. We're just going to type in CRISPR array. CRISPR array right here, because this is how it should be. This is how it is in the feature data. It's lowercase CRISPR underscore lowercase array. Output that, and then we should have the CRISPR arrays. And here it is. So that's how you can pull out information. Now remember, if you want to save these outputs into a file, you just add the less than symbol, okay? And then we're going to put in the file that we want. Oh, my bad. Greater than symbol. And then we're going to name it. You can name it whatever you want. It could be CRISPR array for lactobacillus. .fasta. And then this will be our output. I already have this saved, so I will show you. I already have these files saved. I already have the coding domains. I already have the CRISPR arrays right here. And I have the RNA saved right here. Okay? And then a few more things that we can look at here. Let me clear this. Type in ls. We're going to look at this annotation file again. And remember, I can look through where I have a command that cut out. Here it is. So remember earlier when I used the RAS export genome feature data lactobacillus underscore anno.gto, and then I cut out field 3. And when I cut it out, it gave me all of the feature types that were annotated in the numbers, okay? All of these. Now, what if I want to count the number of coding domains that were annotated? What I can do is I can use a command. I can output this command. Instead of using sort, I can use another command to select only CDSs. So let me just show you real quick. Here we have repeat right here. Repeat, repeat. I don't want that to be in my output. I want all CDSs. So I can do is I can type in the command grep. And grep, you should be familiar with what regexes are. And grep will use whatever you put in quotations as a regex, a regular expression. So CDS. So anything that meets this pattern, capital CDS, will be outputted here. So I should only get CDS in my output. Nothing else, only CDS. which is exactly what I want. Next, all I'm doing is taking this RAS export genome feature, cutting field 3, taking the output from up here, taking this output, filtering out, and only looking for anything with CDS in it. And I'm going to take out this output, and now I'm just going to count the number of lines, because this is 1 line, 2 line, 3 line. You count each one. Basically, I'm just counting each CDS, because on each line is just one CDS, one CDS, one CDS, one CDS, right? So take that output, and I can just type in WC for word count, and this time in this command, I'm going to give it a flag. So I'm going to give this dash, and then L, word count, and I'm going to count each line. I'm going to press enter, and then it should give me a number back and the number of lines. So here it is, 3001 coding domains. Okay? And I should be able to do the same thing for RNA. '74. Okay? So this might look fancy or it might not, but it's really not too complicated. All I'm doing is using this feature right here, taking this command, RAS export genome feature, and like I showed you all the way up top is first I just showed you what the cut dash F3 is doing. It's just cutting out the column that had all the features labeled, right? And in this part right here, just remember that this is just giving me the annotation file, right, in GFF3 format. Right, GFF3 format. You can do a simple Google search on GFF3 format and you will find this format, right? GFF3 format. So you have this type of format where you have columns, 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 and these columns give some particular information, right? Now, this might not be exactly this right here. Let's see, where did it go? Right here. So this might not be exactly GFF3 format, but it follows that format, right? You have columns, 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 columns. And then you have the plus or minus where the strand is located, right? Where it's located, start and stop, start and stop, start and stop, right? Where it's at. And then you look over here, start and stop, get this different information about locations. That each column gives you something useful, right? Well, this is similar to that right here. But we're only interested in this field right here, the third column, right? And we can just cut that out with the F3 tag right here. And it's just going to cut this out. And it's going to be like all the features that was it, what that feature was labeled as, right? All these CDSs. And then we're going to, and then this, remember this right here, this is just a pipe. We're going to be piping all of these results into a next command, into a next command, into a next command. So cut field 3, and then what we do next is we just grep for anything that had CDS in it, or RNA, or whatever you're interested in the features, right? We're limited by repeat, CRISPR arrays, CRISPR repeats, and so forth. And then take grep, we already have our output from that, and just, we can count each line. And then we get our 3001. Okay, now obviously I broke this down into steps so you would be able to understand and hopefully you can use in your homework or in your studies. And if you have the capstone project, I know for the bioinformatics route you will need to use RAST. I'm just trying to make things easier for you. And obviously you could just go one go, export RAST export genome and type everything you need all in one go. Just remember, all I did was just break it down step by step. It would go by quicker once you already know and get familiarized with the commands and what they can do. Alright, so now in this case I'm going to show you an example where maybe you might only be interested in Lactobacillus' ribosomal RNA. And you don't want to annotate the entire genome. You're only interested in a certain subsection of the organism's DNA. In this case, maybe just ribosomal RNA. Specifically, maybe ribosomal or small subunit ribosomal RNA. So here we can go to command line list, and you might be looking for if there's any commands that might do that for you. And you might find that there's a command called ras call features ribosomal RNA -seed. You click on that, click on help too, and it's going to give you an output here, and it's going to output how to actually use the command. So all we need to do is type in the ras call features RNA rRNA-seed, and then we can actually give what we want to call for. In this case, just an example, you can call for other types of ribosomal RNA, but I'm just calling for small subunit RNA, and then we will give the actual feature that we want. I mean, not the feature, the genome object. So in the very beginning, we created the genome object, giving the scientific name, the genetic code, and so forth. This time, we're going to, instead of submitting the genome object straight to RAS server to annotate the entire genome, only going to set it to RAS to annotate for ribosomal RNA, small subunit ribosomal RNAs, that is. Lactobacillus.gto, and then we're going to name it. In this case, I already ran the job and got it done. If I click here, all the way down, I have right here and then right here. So these are both the same file, and you can name it small subunit ribosomal RNA _ano.gto, whatever you want to name it. Click enter, and you're going to submit the job. Once it's done, you'll get a file back. Okay. These are both the same files. I just ran the job twice as an example. And we can look at the features, just like in the previous examples where we looked at the Lactobacillus annotation, the GFF3 format. We can look at it the same way, but when we actually look at the feature data, we should only get ribosomal RNA as the features, or RNA. So click enter, and then we will wait for it to come back. And notice how we got ribosomal RNA, and each of them are small subunit ribosomal RNA, which is exactly what we want. And we can actually output this into a FASTA file. We can output this into as the DNA file too. Right? You type in rast export genome -help. And then whatever you want, you just need to construct your command and ask the server to do that for you, right? You might want it feature DNA, you might want it in FASTA format, and so forth, okay? Or you might want to take the whole annotation in GFF3 format. It's up to you, okay? But this is how you might get a question asking to find in your homework ribosomal RNA, and now you can do this. You don't have to be limited. If you go onto NCBI and NCBI doesn't have an annotated ribosomal RNA feature for that organism, you can try to look for it yourself using RAS. RAS can help you annotate it and give you that potential ribosomal RNA. And I hope this is helpful.